Okay, so in today's video, I will be showing you my linear algebra project, and then this project will be done by Python. So later on, I will first describe the question given to me for the project and explain some of the codes that I did, and in the end, I will show you one example to demonstrate the program and how the results looks like. So let's go to Python first. Let's go. Okay, so I will first describe the question. So the question that I given is that there is given 5 points in R2 whose x values are equally spaced apart, and then we have to find the parabolic runout spline connecting these 5 points. Okay, so from here, the thing that we have to be cautious about is that the x value has to be equally spaced apart, which also means that the x values, the difference must be the same. So only then we can find the parabolic runout spline connecting these 5 points. Okay, before explaining some of the codes that I did, let us first see the parabolic runout spline simulator that I did. Okay, so you can see the parabolic runout spline simulator. The question is given on the top, and then we have 5 points for us to input. So you can see here the 5 spaces over here, that is the place that for us to input our points. And then the way to input our points is any way that you like, as long as you put the x value first and then comma y value. So for example, I put the x value to be 0 and then y value to be 1. You can also put it in a bracket way, like bracket 0, 1 bracket, like how we usually do when putting the coordinates. And then on the right side, we have 3 buttons. One is verify points, the second one is the find graph button, and then the third one is the extra info button. So after inputting the 5 points inside, we have to first verify the points to see that if x is equally spaced apart or not. After clicking the verify point button, if you successfully verify the points, it will show that you can now see the find graph button and also the extra info button to be enabled. So the find graph button is for you to find the graph of the parabolic runout spline, and then the extra info button is for you to find out some of the values that you might need when calculating the parabolic runout spline. The info will include the A, B, C, and D, which is shown over here, and also it will also include the x and y points for each of the points that we plot in the graph. Okay, what if you fail to verify the points? Then the text box there will show that you fail to have x equally spaced apart, and then also the find graph button and also the extra info button will still be disabled, which means that you cannot use the program. Okay, after explaining the whole simulator that I did, let us go to the codes that I did for this project. So here are the 3 things that I used for this Python project. Number 1 is the matplotlib, number 2 is the numpy, and the last one is the tkinter for the simulator that I did. Okay, so the hashtag contains the question, and let's first look at the tkinter program that I did in the code section. Okay, so the first thing is that I name my tkinter project as my root, and then the size of my project will be 1000 times 800, and then I also named the program of my title will be the Parabolic Runout Spline Simulator. Then I did some labeling, which is the question, the first point, second point, third point, fourth point, fifth point, and then I also put the 5 entry boxes to indicate the boxes that you have to input for the points. Then after that, for the button section, I have put 3 buttons. One of it is the verify points button, the another one is the find graph button, and also the extra info button. And then in the end, the output one is indicating the text box that I have in the bottom section of my simulator. So you can see the buttons part, all of the 3 buttons have 3 different commands. One of it is the parabolic check, the second one is the parabolic, and then the third one is the XY plot points. So these 3 commands will be the 3 functions that I mainly use in my project. So let's first see the parabolic check function that I did. So you can see here, I first get the 5 points that the user inputs, and then I will replace the brackets if there is any to empty, and then I will put everything into a coordinate list. So after sorting out the coordinates using the x values from the smallest to the biggest, I drag out all of the x values and then put them into one list. So I will check the difference between each value of x, and then I will put it into an if-else statement to see that whether the difference are the same or not. If they are not the same, I will put my text box the text x is not equally spaced apart, please try again, and then both of the buttons, the find graph button and also the extra info button, will still be disabled. If they are the same, then I will insert my text box the text points verified. You can now use the find graph and also the extra info button, and then I will enable both of the find graph and then also the extra info button. So that is all for the parabolic check function. Now let's look at the parabolic function. So you can see the front part of the parabolic function is the same as the parabolic check function. So I also take the points from the user, eliminate the brackets, and then put them all into a coordinate list. So the different part is over here. You can see that I will put all of the x values into one list and also all of the y values into one list. So you can see one list is for the x values and then one list for the y values. And then I will take the difference of the x values and then name it as h. And then I will name my C as a matrix 510, 141 and 015 as shown in the picture. And then I will define B as my matrix. Okay, so after this, I will calculate the right part of the equation which is shown in the picture. So since we are finding 3 equations, so it is in the range 3. And then below the part is all of the codes that I did for the calculation part. Okay, so the M1 part is me taking the C matrix and then move it to the right side, become inverse times the right side part of the matrix. Okay, so after finding out the answer, due to the assumption that we did for the parabolic runout spline, the extra 2 elements will be the first element equals to the second element, and then the last element will be equal to the second last element. So after calculating this, it is time for us to prepare some of the calculations for plotting our graph. So I will first plot the 5 points that the user inputs and then put them as a circle. Then I will find A, B, C and D, which is shown in the picture. So to plot the graph, of course, to make the graph smooth, we have to plot as many points as we can. So here I will put the number 51 so it will be more smooth. And then in the end I will plot the graph and then put the graph as a black color. So after seeing the parabolic function, let's move on to the last part of our function, which is also the XY plot points. So basically everything is almost the same as the parabolic function. Just towards the end, I will put the A, B, C and D and also all of the plot points for the X and Y into the text box. This is so that you can know what is the answer for the A, B, C and D, and also how is the graph formed using the plot X and also the plot Y. So in the end, we will use an example to see our program and then see how it goes about. The example that I'll be using is in the linear algebra textbook. So here are the 5 points that I already put in the text box. So let's first verify the points to see whether they are equally spaced apart for the X values. Okay, seems like they are. So the find graph button and also the extra info button is available for us to click. So we will now click the find graph button. Okay, so it will let us see the graph immediately, and then we can see that the graph is identically the same as the example in the textbook. Okay, after that, let me first X out the graph. Okay, the last part is to check the extra info button. So let's press it. Okay, so you can see that the points plot X and also plot Y and then are given, and then also the A, B, C and D are also given. So you can see that the parabolic runout spline simulator works out quite fine. So here marks the end of my demonstration of my linear algebra project. So if you like my project or if you like my video, please consider giving a like. And then that is all from me, and then we will see you next time. Goodbye.